In this lesson, we're going to continue our examination of polynomial inequalities. We're going to look at some of the situations where a by hand method may not be the optimal solution or may not even be possible. We'll start with some old stuff though. We'll go through some sort of reminders from yesterday. So we have a stunt pilot testing the plane. The equation models its height is given, where x is time in seconds, f is the height in meters, when is he below 500. In other words, we want to know when our function is doing that. So it's a quadratic. We know we want to make it equal 0. So that's our first idea. Bring that 500 over, and it gives us something to solve. Now, instead of solving below 500, I've taken my equation and I want to solve below 0 now. First thing we want to do is see if we can factor this. And if we tried common factoring, 195 divides by 15, yeah, it does 13. 450 by 15 is 30. Add, and definitely numbers that do that, minus 10, minus 3. Okay, x is 10, x is 3. Okay, based on our table method from yesterday, our lowest 0 is 3, 3 to 10, greater than 10. Our function is made up of the number 15, minus 3, and there's our function. We want to check our signs, right? So a number below 3, let's try 0. Well, 15 is 15. I can't ever change 15. But 0 minus 10 is negative, and a negative, which makes a positive. Between 3 and 10, if we try 4, I get a negative, a positive, and that's a negative. And 11. Okay, so what can I say? I can say the stunt pilot is below. We solved it according to 0, but it's actually below 500 meters when, key there's the below part, right? Below is this thing. When time is between 3 and 10. I think this is a second, isn't it? It was, yeah, time seconds. Okay, so that's what we did yesterday, right? Solving from 3 to 10 seconds, he's below. So we start off above, went down, went back up. Which, based on our knowledge of graphs, 10, 3, right-hand side is positive. It's a quadratic. That makes sense, right below. Okay, we'll try another one. Based on research, the marketing team at Best of You predicts that when the price of a bottle of new SPF 50 sunscreen is X dollars, the number D in hundreds of bottles sold is given by this. How many bottles are sold per month when the price of each bottle is 5? Okay, $5. Well, X is dollars. So really they're asking us for D at 5. We can figure that out. We'll plug it in. Function notation, all our X's. Get those handy calculators, and I got 220. Remember, that's in 100 bottles. Or if you will, that really means 220 and 100 is like that, or 22,000 bottles. Okay, part B, determine the values of X that will result in sales of at least 17,200 bottles of sunscreen. At least. In other words, greater than 17,200. So I want for part B to have my sales be at least, equal to 17,200. Or, because it's in hundreds, 172. Okay, my function itself, negative x cubed plus 8x squared plus 9x plus 100. I want x equal to 0, so I can bring the 172 over. And now I've got myself an equation. Okay, now, most of the time, we don't like solving when our leading coefficient is a negative. So rather than doing this, we'll fix it. We'll move it all to the right, okay, and end up with the 0 on this side now, and x cubed minus x squared minus 9x plus 72. It's often easier to work through leading coefficient being a positive. Okay. So we already want to know our function less than 0 now. Okay, this is the cubic function, which means I need to go through that process of finding a synthetic divisor number. And there's a whole bunch of cases that might work this time. Ooh, what we've got 6 and 12, 8 and 9. Any one of those and any alternating sign of those, right? Now 1 definitely off the table. Maybe we'll try 2, see what happens with 2. 8 minus 32 minus 36. Yeah, it's not quite 72. How about 3? 27 minus 72 minus 20. Hey, that'll work. F at 3. Okay. Yeah, synthetic division. 3, 1, negative 8, negative 9, 72. Okay, so what do we got? We got x minus 3. We've got x squared minus 5x minus 24. And we want that to be less than 0. So I'm just going to move it over this side, okay? I got myself a quadratic there. Maybe able to factor that with some man. That's minus 8 and 3. Less than 0. And I'm ready to go. My zeros are 3, 8, and negative 3. So negative 3. And from negative 3 to positive 3. And from 3 to 8. And greater than 8. And what do we got? X minus 3, x minus 8, x plus 3, and our function. And let's take some numbers. Negative 4, negative, 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 0, 4, and I don't know, 10. Okay, in order to produce, what was our part? We had to produce at least 17,200 bottles. We need to have x values that are and what were we solving? We wanted to solve when x is less than 0. Okay, so we need x to be less than or equal to negative 3. And the other interval was 3 to 8. Okay, but let's go back for instance and think about what x was. X stands for the price of the bottle in dollars. Well, can I charge negative $3 per bottle? That doesn't really make sense. So this one really is an inadmissible answer. What should we actually charge? We should charge between $3 and $8 per bottle, and we'll produce our 17,200 that we require. Okay, so basically what we did yesterday, just some quick refreshers of things. Today's new idea is what happens if we can't solve these things algebraically? They don't have nice factorable zeros. That means we can't draw it, nor can we make a table. So we have to use technology. So we're going to learn 2 different ways of using technology today, both with your graphing calculator. We're using the TI-84s because we're allowed to use for our exams. And I'm going to show you 2 different techniques for doing that. Okay, method 1, we'll try on the first example here. We're going to use the equations and POI. Okay, so take a look at this first example here. I'm going to solve this using technology. put this into y1. I'm going to put this into y2. I'm going to think of it as two distinct separate functions. So on our graphing calculators, we'll turn it on. Okay, we'll clear our memory. So second plus 7, 1, 2. Make sure nothing else in there. We're going to go to the y equals screen. In the y equals screen, we're going to put in the first function, the left-hand function. So we use a negative sign, negative, and use your variable button to the power of 3. Arrow over to get off there. Plus 6x squared minus 3x. Okay, so it's a nice cubic function. My second function is a horizontal line of 11. So I'm going to put the number 11 in there. Two functions, we're going to press graph, and we'll hopefully see them. Now, I definitely see part of a cubic function, but I don't see the horizontal line in 11 at all. And the reason why is our window. We know from past experience we often have to change a window. I need to see where the first equation meets the second equation. In other words, where these two things are the same, right? So I definitely have to see up to 11. When I say up to, that's on my y-axis. So I'm going to make my y max bigger and put 20 in there, just so I can see where my cubic function, which is right there, meets my horizontal line. And I notice that there are three distinct solutions. If I'm solving this, I want to know where x is greater than, where the left-hand function is greater than the right-hand function. So looking at my graph, I need to know this x value, and that's going to be this interval, and here I'm above, right? If I can find those points. How do we do that? Well, I do that by going to my second trace menu, the calc. And I want to find an intersect, number 5. I can move my cursor close to the point of intersection. I don't have to be right on. I can get close to it. I don't have to be right on it. I'm going to press enter, enter, enter. So one POIs, and all I really care about is the x value, is x equals negative 1.05. Okay, we're going to do the exact same thing, second trace, number 5. I can move my cursor close to the next one. The calculator always finds one it's closest to. Enter, 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 and I get 2.11. I'm working from left to right like I would with my graph, right? Same thing for the third one. We'll go close to the third one. Enter, enter, enter. 4.94. Okay, I got all the math I need. I just got to analyze it. And I'm doing it in terms of my picture. So I want to know when my first function was above the 11 line. Well, it's above the 11 line. So we're going to say this function is above that when x is less than negative 1.05. That would be this piece. And when it's between 2.11 and 0.94. And notice I use both kinds of notation here, but I'm not picky which one you use. Bracket or interval, your choice. Just make sure it doesn't have any equal signs or any square brackets. And you look at your picture, you can tell where they are. Okay, that's done. We figured that out. Okay, let's try the next one. In the next one, we're going to use a second method. Method number 2 is an app that's built into your graphing calculator called Polynomial 2. What it does is it finds the roots, the solutions of polynomials. But to use it, this app, I have to make sure my equation is set equal to 0, kind of like we would do if we're doing algebraically, just doing with technology. So to access this app, we're going to go to apps. And apps is right here. Okay, before I do that, I'm going to clear out the memory just so I can start all over. Okay, clear the memory. We're going to go into apps. Okay. I have to load mine. Yours should already have it in there. If it doesn't, come see me because I have to install it for you. Okay, so Polynomial 2. It might not be number 2 on yours. It might be in the list of things on your graphing calculator, but it should be in there. So Polynomial 2, number 2. To get into it, just press any key. It's just telling you this is what it does. We want to find some roots, which is option number 1. we have to tell our graphing calculator what order it is, what degree your polynomial is. We have a degree 4, so we're going to highlight 4 and press enter. Okay. Don't change anything else in there. You don't need to worry about anything else. To get to the next screen, you have to, where it says next here, you actually have to go and press the button underneath it, okay? We're going to press the graph button. Okay. What it wants is it wants the coefficients from your quartic function. So the numbers in front of each variable. So in our case, we have 1x4. So A4 is the number 1. Then we have a negative 2.1. And then we have a negative 2.4. If your equation was in the right order, make sure you do that first, right? We have a negative 1, and then we have a 3. Okay, we've got all our coefficients in there. We're ready to solve it. So press solve, which again is a button underneath the graph. And it's going to tell you what your different answers are. Okay, so our zeros are 2.92 to 36 figs. In the next two, do you notice how there's a dot, dot, dot at the end? If you actually go over to it, notice there's a plus sign in there. This is a not real root. It has the letter at the I at the end. That means something. We don't have to worry about it. It means an imaginary number. But if you ever come across a root that has a dot, dot, dot at the end, like x3 right now, those roots don't count. Those are not zeros. They're imaginary ones. So for our purposes, the only two that we have are 2.92 and 0.7, or if you will, 0.800. Okay. Now, in the last one, we kind of had our picture to think about what was going on here. We don't have a picture, but we can think about a picture. Okay. We know 2.92 is about there, 0.8 is about there. Right hand goes up. It's a quartic, so left hand also goes up. We only had 2 zeros. Okay? None of them are special. You would see there being a special 0 in the list of zeros. It'd be repeated. Okay? So all we know is it's going to go like that somehow. We don't know what it looks like. We just know it's going to change direction there. Okay, so when is this below 0? Well, below 0 obviously in this part. So we could say our function is less than or equal to 0 from, or when, again, your choice of notation, 0.8 to 2.92, or bracket notation, your choice. Okay. So we have two different methods of solving this. You decide which method you like better. Do you like using inequalities? I'm sorry, do you like using polysomalt, or do you like making equations that work the same way? We'll try some more examples to get the hang of this. Okay, I'm going to use my POI method for the first one. Okay, so I need to see my calculator. Let's clear our memory. We're to get out of the screen to get out of the screen. You can press second and mode, the word quit beside it, and do it again. And then we'll clear memory. Okay, y equals, I got an x cubed minus 3x squared plus 1. My next function is an x to the 4. Oops, 4. And then minus 2x. Let's see if we can see it. Give ourselves a cubic function. Got ourselves a quartic function. Okay, they look like they're intersecting twice from what I can see. I'm going to find out where they are. My calc, number 5. I put my cursor close to what I think one of them is. And I get x equals, so all I care about is the x number again, negative 0.322. We'll try it again. We'll find the other one, number 5. It's right about there. And I got, oh, x is 1. I want to know where the cubic function is below, where it's below the quartic function. So cubic function was the first one I drew, which means this section is below. And then it's above. And then it's below again. Okay, so how would I answer this question? let's say x cubed minus 3x squared plus 1 is less than this function when it's less than negative 0.322 and when it's greater than 1. In between those, it appears to me that the quartic function is above that. Okay. Now, if you didn't like that method, what else could we do? We could use Polynomial, but to use Polynomial, you gotta make it equal to 0 first. So I'd have to rearrange this. So it'll look like that. And then if I went to my apps Polynomial menu, my root finder, I still want to be degree 4. And I put in my coefficients of 1, negative 1, 3, negative 2, and negative 1. And I could solve it. Hopefully get the same answers. Oh, I see those dot, dot, dot ones on the first two, so I don't worry about these two. Okay, but x3 and x4, good, the way I want them to be. Remember, we have to picture our picture, right? So I was drawing this. My 0 is negative 0.33 is here, positive 1 is here. Off the red graph, it goes up to the right, quartic up to the left. There's only the two zeros, so it does something weird here like that. When is it below 0? Sorry, when is it above 0? Because that's what I have here, above 0. Above 0 in this section, above 0 in that section. Same answers. Okay, so two different ways of solving the same problem. Okay, you pick one of the two methods and try and solve the last one. I prefer the Polynomial way. I think it's pretty handy to use. Okay, but I know that to do it, I gotta make it in, okay, bring things over standard form first. Okay, so Polynomial, my coefficients are, what do we got? A 2, I got no cubes, a 3, got no x's, a 2. Solve. My answers are the ones that don't have dots. Ooh, they all have dots. What does that mean? They all have dots. It means there are no zeros. So when is this graph above 0? Well, let's think about the graph for a second. It's got no zeros, and the right-hand thing goes up. Maybe something like that. So the fact that it has no zeros, no solutions, means, let's put the right way here, that 2x4 plus 7x squared is greater than 4x squared minus 2 for all values of x, or always above it. There is no time where it's below that function. And if you try it with the other method, it would show you the same thing, that there are no POIs. You can look at your picture and see, we'll give it a try, that there are no POIs in this thing. Take a look here. 2x to the 4 plus 7x squared. We'll clear out this one. 4x squared minus 2. Take a look at our graph. Here comes our quartic function. It's up there. And our quadratic function is always below it. Okay, there is no solutions. They never cross. They never meet. Okay, there's some more inequalities with technology. There's a couple of applications at the beginning there. Get used to by hand ways. You kind of do need to know how to do both. So we want to be comfortable with our technology, but also know where it's coming from. Hey, just a couple quick questions to try tonight.